Hey, you guys, this is Miss Kirkman. This is your lesson for Friday, November the 6th. Core 2 and Core 4 are testing their check ins that they missed from last Thursday. So obviously, there's no Google Meets today, but I posted this video for Unit 3, Lesson 8, titled More About Constant Speed. So I'm going to go through all the activities with you just like I did before. So please follow along in your book um, as we do these activities. So today is lesson 8. We are skipping lesson 7. So we're going to be talking more about constant speed. So in activity 8.1, we are back on the treadmill again. And so the situation says, while training for a race, Andre's dad ran 12 miles, 12 miles in 75 minutes on a treadmill. If he runs at that rate, number one, how long would it take him to run 8 miles? And then how far could he run in 30 minutes? So in looking at this, we are going to create a chart just like we've done in previous lessons. So distance in miles is here, time is here. So it says 12 miles in 75 minutes. Okay. So first, we need to figure out how long it takes to run 1 mile. Okay. So we're going to put a 1 here. And just like we have talked about before, how do we get from 12 to 1? Well, we have to multiply the 12 times 1/12. And that gives us the 1. Okay. So what we do with the 12, we also have to do with the 75 for the time. So in order to go from the 75 to whatever that may be, we're going to multiply by 1/12. Okay. So it's handy to have a calculator with you. So you take 75 times 1, which is 1, and divide that by 12, and you get 6.25. Now that's how long it takes Andre's dad to run 1 mile, which is 6.25 minutes. Okay. But if you look at question number 1, it wants to know how long it takes him to run 8 miles. So 8 miles is going to go over here. So now we have to look at, well, how do we get from 1 to 8? Well, we get from 1 to 8 by multiplying 1 times 8, which means we have to multiply our 6.25 times 8. So in our handy dandy calculator, 6.25 times 8, and that gives us 50. 50 what? It takes 50 minutes for Andre's dad to run 8 miles. So that's the answer for question number 1. Now we have to go to question number 2, where it wants us to look at, well, how far could he run in 30 minutes? Okay. So we're going to build our chart again with our distance and our time. We've got 12 and we got to 75. Okay. Now we're actually going to be working the opposite way. Okay. Where over here on question number 1, we were finding 1 for the distance. Well, this time we're finding how far could he run in 30 minutes? So we need to know how far he can go in 1 minute. Okay. So just like we've done before, how do we go from 75 to 1? Well, we multiply 75 times 1/75. So we have to multiply our 12 times 1/75 in order to get our answer that's going to go here. So 12 times 1 is 12. So we have 12 divided by 75. Put that in the calculator, and you get 0.16. So in 1 minute, Andre's dad could go 1/1600 of a mile. Now it wants us to know 30 minutes, okay? So we put our 30 minutes under the time. How do we go from 1 to 30? Well, we multiply the 1 times 30, which means to go from 1/1600, we multiply times 30. So we have our 0.16 times 30 equals 4.8 or 4 8/10 miles. So the answer to question 2 is, how far could Andre's dad run in 30 minutes? He can run 4 8/10 miles. Please feel free to pause this video at any time as you're working on completing the activities in your workbook. Now we're going to move on to activity number 2, 8.2, which is picnics on a rail trail. Kieran and Claire live 24 miles away from each other along a rail trail. On Saturday, the two friends started walking toward each other along the trail at 8:00 a.m. with a plan to have a picnic when they met. Kieran walks the speed of 3 miles per hour. That's Kieran. While Claire walks 3.4 miles per hour. After 1 hour, how far apart will they be? So what we're going to look at seeing is that they also live 24 miles away from each other, okay? Well, we know from our description here that Kieran walks 3 miles an hour because she's walking at the speed of 3 miles per hour. Claire walks 3.4 miles in an hour because she's walking at a speed of 3.4 miles per hour. Okay, so after 1 hour, Kieran has walked 3 miles and Claire has walked 3.4 miles. So what we do is both of them live 24 miles away from each other. So what we have to do is figure out how far apart they will be. So we have to take the 24 hours and subtract the 3 hours that Kieran walked and the 3.4 miles that Claire walked. So when you take 24 minus 3, you get 21. And then we have to subtract the 3.4 or 3 4/10. So we subtract 3 4/10 and we get 17 6/10 miles. So they have gone from being 24 miles away from each other to now 17.6 miles from each other. Now, question 2 asks you to make a table showing how far apart the two friends are after 0 hours, 1 hour, 2 hours, and 3 hours. Okay, so we're going to create this table. And this is elapsed time, and this is distance apart. So with no time having elapsed, they're 24 hours apart. Okay. So after 1 hour, how far apart will they be? Okay. So we have to figure out, well, how do we go from 0 to 1? Okay. We know after 1 hour, because we got this in this last one, okay, because we will continue to subtract these two numbers out each time, okay. So after 1 hour, there's 17.6, okay. If we take that 17.6 and we subtract 3, and then we subtract 3.4, after 2 hours, they are now 11.2 miles apart. So we have to do our third hour. So we take our 11.2 minus 3 hours that Kieran is walking, the 3 miles per hour. And then we subtract the 3.4 miles per hour that Claire is walking. And in 3 hours, they will be 4.8 or 4 8/10 miles apart. Question 3 says, at what time will the two friends meet and have their picnic? Since the distance between them is decreasing by 6.4, okay, and the 6.4 comes from the 3 miles per hour that Kieran is walking, plus the 3.4 that Claire is walking, that equals 6.4. So with every hour they are walking 6.4 miles. So since the distance between them is decreasing by this amount each hour, we know here at the 3 hour mark, they have walked 4.8, okay, which means they really don't have another 6.4 miles to go. They have less than that. So if we were to try to figure out how far they are going in a half an hour, then I can take half of the 6.4. 6.4 divided by 2. So they walk 3.2 miles in a half an hour. Okay. So that will put us at 3.5 hours. Okay. If I was to take the 6.4 and divide it by 4, because there are 4 quarters in time every 15 minutes, Okay, that'll be 1.6. So we already going 3.5. They're going to go 3.2. So if we take our 4.8 and we subtract the 3.2, 4.8 minus 3.2, that gives us 1.6 miles to go. Okay. So what I said earlier is to take this 6.4 and divide it by 4 so that you get 15 minutes, 15 minutes, because 15 minutes plus 15 minutes is 30 minutes. And then another 15 minutes is 45 minutes. And then the last 15 minutes is an hour. That's how that's why I divided the 6.4 by 4. Okay. I am left with 1.6. So plus another 15 minutes, excuse me. Let me erase that so it's not confusing. Plus another 15 minutes. So that will be 3 hours and 45 minutes, or 3.75. So they will meet after 3.75 hours. Now, if we go back to the beginning, they started at 8. Okay. So if they started at 8, and I'm going to do some work down here on this bottom, and I'm going to change it to red. Okay. So that's 8, 9, 10, 11. That's my 3 hours, and then 45 minutes. So at 11:45 a.m., they will meet. Now let's look at part 4. Kieran says, if I walk 3 miles per hour toward you, and you walk 3.4 hours toward me, it's the same as if you stay put and I jog 6.4 miles per hour. What do you think Kieran means by this, and is he correct? So what we're looking at is a combined total of miles per hour that both Kieran and Claire are walking is 6.4. Okay, because that is his 3 miles per hour and Claire's 3.4. So they have a combined total miles per hour of 6.4. So what Kieran is saying is that if I'm walking this amount and Kieran is walking this amount, if Claire just stays put and doesn't go anywhere, and Kieran jogs for 6.4 miles per hour, will they still get there at the same time? Okay. So what Kieran means is that each hour, the total distance between them is decreasing by this 6.4 miles per hour. So the amount of time it will take them to meet is the same as if one person stays put and the other person travels at that same 6.4 miles per hour. However, the location of their meeting would have to change to Claire's house instead of somewhere in between, because if Claire's not going anywhere, then Kieran has to come to her. And I hope that makes sense. So it's just like if you were in a race and one person's at one end of the track and you're at the other end of the track. And if one is going towards you at 3 miles an hour, and your opponent is coming towards you at 3.4 miles per hour, you're going to meet at some point. And what Kieran is saying is if Kieran decides to go the whole 6.4 miles towards you and you don't move, you are told to stay put, then the picnic has to be at your house because Kieran is going to be coming to you. So that is why the location would have to change. They wouldn't be meeting somewhere in the middle because the location would have to change because Claire's not moving anywhere. It would have to be somewhere in between the houses on the rail trail. Now, the fifth question for this is several months later, they both set out at 8 o'clock a.m. again, and this time Kieran is jogging and Claire is still walking. Okay, so Kieran is jogging, but Claire is still walking at 3.4 miles per hour. This time they meet at 10:30. So it wants to know how fast is Kieran jogging. Okay, so that means it has taken them 8, 9, 10, 2.5 hours instead of 3 hours and 45 minutes. Okay. So that's 2.5 hours. So that's 2.5. In 2.5 hours, Claire traveled her 3.4 times the 2.5 for 2.5 hours. So 3.4 times 2.5, and that equals 8.5 miles. Okay, miles. So again, remember from the very beginning, they're 24 miles apart. So we take the 24 miles minus the 8.5 miles, and that gives us 15.5 miles. This means that Kieran is jogging the remaining 15.5 miles in 2 hours. So 15.5 miles in 2.5 hours means that Kieran jogged 6.2 miles per hour. So how did I get that? So I took the 15 and a half miles, and I divided it by the 2.5 hours, because remember, that's the total amount of time it took, because they meet at 10:30 instead of 11:45. So when I divide that, I get 6.2. So that means that Kieran jogged 6.2 miles per hour. The last activity is activity 8.3, swimming and biking. Jada bikes 2 miles in 12 minutes. Jada's cousin swims 1 mile in 24 minutes. Who is moving faster, and how much faster are they moving? So we have to kind of look at this, okay? If Jada's cousin swims 1 mile in 24 minutes and Jada bikes 2 miles in 12 minutes, you have to use a little bit of common sense in thinking about this, because Jada is going 1 more mile, going 2 miles, where her cousin is only going 1 mile. Jada is also doing 2 miles in half the amount of time that Jada can swim 1 mile. So it makes sense to say that Jada bikes faster than her cousin swims. But we have to figure out by how much. Okay? So I'm going to attempt to do a table. Miles, minutes. Okay, so 2 miles in 2 minutes, which means she goes 1 mile in 6 minutes. Okay. So Jada bikes faster than her cousin swims, but we need to figure out by how much. 1 minute, 1 mile in 6 minutes. Jada's cousin swims 1 mile in 24 minutes. So 2 miles. This one is a hard one, I'm not going to lie. Because I'm trying to figure out the whole how much faster. Okay, so what you have to look at is I'm actually going to go to Mr. Morgan's Math. And I had just pulled this up to look at it myself, and watch him. And I think I can do this. And I'm sorry for me rambling. I just forgot for a quick second. Okay. So you know how we've got the one that is here. We now need to find out the one here. So how do we go from 6 to 1? Well, we multiply by 1/6, which means we have to multiply the 1 times 1/6, which gives us 1/6. Okay. The same thing over here for the miles and the minutes. 1 mile in 24 minutes. Well, how far can she go in 1 minute? So how do we go from 24 to 1? Well, we multiply by 1/24. Okay, so we have to multiply the 1 times 1/24, which gives us 1/24. okay? 1/24 of a mile.
Every 24 minutes. Okay, so our difference in our rate is going to be here. Our speed is 1 mile in 6 minutes or 1 mile in 24 minutes. So for sure, we know that Jada is going faster, 1 mile every 6 minutes. That's the first part there. And how much faster is she going? Well, that's going to be a different question, right? We want to figure out how much faster is she going in terms of kind of their miles per minute. Okay, so here we have 1 mile per minute, and this is 1 mile per 24 minutes. So what probably is good is to put this in terms of, when we're comparing speeds, we usually do that in kind of miles per hour. That's typically what we look at for when we're looking at speeds there. So we want to put the 1 back on this side over here. So to go from 6 to 1, that's going to be multiplying by 1/6. So we have 1/6 mile per minute. With me so far? And here, we make this into a 1. This becomes 1/24 miles per minute.
And this is what I just showed you.
So speed is usually miles per hour, and we're in minutes. So there are 60 minutes in 1 hour. So we're going to take this number, and we're going to complete our table here. We're going to make this into 60. So we're going to multiply this by 60. So we have 60 over 24.
Okay, so what he is showing you is that now after we do this section right here, because we need the minutes in 60, so now how do we go from 1 to 60? We multiply by 60, which means our 1 to 24, we multiply by 60, and we get 60/24. Okay, so 60 divided by 24 is 2.5. And we do the same thing over here. 60 minutes, we multiply by 60. So we have 60/6, which is 10. Okay. I am going to go to another screen. So we have 10 over here on this side and 2.5 over here on this side. So Jada is going at 10 miles per hour, and Jada's cousin is going 2.5 miles per hour. So we take the 10 and we subtract the 2.5, and we get 7.5. So Jada is biking faster than her cousin by 7.5 miles per hour. So let's look at the second question. Okay, we still have the same information to begin with, the 2 miles in 12 minutes and the 1 mile in 24 minutes. So on the same day, one day, Jada and her cousin line up on the end of the swimming pier on the edge of the lake, and at the same time, they start swimming and biking in opposite directions. How far apart will they be after 15 minutes? And then how long will it take them to be 5 minutes apart? Okay. So I'm going to go back to Mr. Morgan's video.
And over here, we're going to have 60, on a space, minutes. So you end up with 15 over 20. Our rate for 1 minute for Jada, for 1 minute, she's going 1/6 of a mile per minute. We know that from this point right there. So after 15 minutes, how far has she gone? That's 15 divided by 6, which is 15 over 6. 3 goes in here 5 times. 3 goes in here 2 times. So we have 2.5 miles there.
So what he has done is he has taken the information. He has taken the information from what we did here, okay, this 1/6. We know that Jada goes 1/6 of a mile in 1 minute. So how much will she go in 15 minutes? And that's supposed to be 1/6. 1/6. We multiply that times 15 for 15 minutes, and that's where we get the 15/6. When we divide that, we get 2.5 or 2.5. Okay. So how long will it take them to be 5 miles apart? Okay. So let's see what Mr. Morgan says about this one.
For the cousin's going 1/24 for 15 minutes. So you end up with 15/24. 3 goes in here 5 times. 3 goes in here 8 times. All right. And so in terms of how far apart they are, now we have to combine 5/2 and 5/8. Okay. So we can do.
Okay. So what he has done here is he has also figured out Jada's cousin. So this is Jada, and now we need Jada's cousin. Okay. So Jada's cousin was 1/24 in 1 minute. So that's 1/24 times 15, which equals 15 divided by 24. It'll be 15/24, which is the same thing as, can divide that by 3, that by 3, so that's 5/8. Okay. I can also simplify Jada's too, because 3 will go into 15 5 times. So 5, 3 go into 2 times, so 5.5. Okay, which is the same thing as the 2.5 right here. Okay. So what he was talking about, how long will it take them? How long will it take them to be 5 miles apart? Okay, and he was talking about taking this 5.5 and this 5/8 and adding them together. Okay, so let's go on and listen to what he says.
Do that by either turning into a decimal or adding fractions together. Let's add fractions together real quick on the side. So we have 5/2 plus, let's go 5/8. The common denominator here is going to be the 8, right? Because 2 times 4 is 8, so 5 times 4 is 20. Now we'll combine 20 plus 5 is 25/8. 8 goes into 25 3 times for 24 with 1 remainder. So we have 3 and 1/8. So how far apart will they be after 15 minutes? They're going to be 3 and 1/8 of a mile apart. So sorry about that zigzag work in there, but that's all the space I had. How long will it take them to be 5?
Okay, so let me make sure.
5 miles apart. So how long will it take to get 5 miles apart? Okay, so we know right now 20.
All right. So what he did was he finished up how far would they be after 15 minutes? Well, that's where he took these two and he added them together. Okay. So I'm going to do come over here and clear this frame. Okay. So we had the 5.5. We had the 5.5 plus the 5/8. And we've got to get a common denominator. Well, 8 is the common denominator, so that means we multiply 2 times 4 and 5 times 4. So we get 20/8 plus 5/8. So we get 25/8. 25 goes into 25 3 times because 8 times 3 is 24 with 1 left over, 1 and 3/8. So they will be 3 and 1/8 miles apart after 15 minutes. Okay. So now we're going to move on to the second part of this question is how long will it take them in 5 minutes? Okay. So I'm going to go to another screen, and this is where we're going to go back to Mr. Morgan and listen to what Mr. Morgan does.
24 minutes. Okay. So our difference, they're turning into a decimal or adding fractions to get this equal to 5 after 15 minutes. Okay. So then to say, well, what's it take to get to 5 miles? It's kind of our idea. How do we get to 5 miles apart? We want to turn that into a 5. So what I thought about is I thought 25 over 8. If I want to turn the top number into a 5, I have to multiply it, right? I want to get this to be a 5. What do I multiply by to get this equal to 5? I got to put an 8 on top so it goes away, right? So the 8 cancels out. And if I put a 5 on the bottom, this reduces to being 5 over 1. So I'm going to say it's 8/5 of an hour, which is basically going to be 1 and 3/5 of an hour. How much is that? I'm not sure. But that's what you got there. Those are some really crazy numbers. I don't think you'll see a lot of crazy numbers like that. I know in the homework there's not so much, so don't worry too much about that last problem. A lot of funny numbers going on there, a lot of things that this is one of the trickier lessons in this unit. Okay, so if you got stuck on this one, that's okay. It'll start to make more sense with time, so don't worry about it too much. So in summary, when two objects are moving at a constant speed and their distance.
All right, so you can hear him having said that that was very difficult. So what basically he did was he took the miles and the time. Let me go back real quick
time ratios are
to
equivalent,
see
they're moving at the same speed.
miles in the minute. That's what I wanted to see. So miles, minute, and this is where he had the 25/8 he put right here, and we needed to get the 15 minutes. Because he needs it to be 5 miles, and we know how much it was after 15 minutes. Because that's what this was right here, and this is where you have to figure out the 5 here, and then how do we get from the 15 to the 5. But what he said was like this was a tricky one, so don't worry about this one so much. I know how long will it take them to be 5 miles apart? Well, the 5 miles needs to be over here. Excuse me. So this was a tricky one. That's where he said that he needed this to be a certain thing over here. But the answer is 24 minutes. It will take them to be 5 miles apart. So don't worry about that part B so much. Just like he said in the video, it's a little tricky, a little crazy numbers. I would have to play around with it to kind of get a grasp on it myself a little better. But just know what he says in his video.
Time distance ratios are equivalent. They're not moving at the same speed.
Is
there's some really crazy numbers. I don't think you'll see a lot of crazy numbers like.
Is here when he talks about these numbers right here, where you are going 25 over 8 miles in 15 minutes, and he needs it to be 5. And so that's what he was looking at as to how do I get the unknown to be a 5. And in order to do that, that would be taking 25 times 8, which is 200, and you're dividing it by the 8 times, which you're dividing it by 40, because that's 8 times 5. And that's where you get the 5 here that he's talking about. But again, don't worry about that one. That one's a little tough. Just as long as you have the gist. And like he said, he didn't think that there was any problems like that particular one on your practice problems.